Good morning, class. Hope you had a great spring break. This is Mr. Straits, and we're jumping back into geometry. We've only got two more chapters that we're going to cover, and we're not going to cover them in great detail, but we're going to catch some things that you need to know. First one we're going to be dealing with is lateral and surface area. We're going to take the area of a square with the side of a length of 4. To find the area of that, you'd have to draw a little picture or sketch. Get a square here with sides of 4 and 4, and the area for a rectangle or square is side times side or length times width, and that would be 4 times 4, which would give me 16. Don't have a measure, so we'll go 16 units squared or 16u squared. Now, what would 6 times that area be? Well, if you took 16 and multiplied it by 6, you would get 96. And it would be 96 square units as well. And what you've just done is you've discovered the surface area of a cube with the side length of 4 is 96 square units. That's the kind of thing that we're going to be working with in this particular section 11.2. Theorem 11.1 is about lateral and surface areas of a prism. Now, I want you to note that the lateral area is P times H. Now, what is P and what is H? Over here on this graph, P is called the perimeter of the base. And if you'll notice, the purple that's highlighted, I just highlighted it in blue there, but that is the perimeter. Okay, and then the height is the H, is the altitude or this height. Lateral area then would be this perimeter times the height. Now if you looked at this thing laid out, I'll just draw it with a highlighter here, real quick sketch, and cut it at this corner at H or something and then stretched it out, it would look like this, okay? Kind of like the wrapper on a piece of gum. If you folded it out, all 4 sides would be laying down there, you'd have something like this, okay? Or the wrapper on a candy bar or whatever, or the box that your stuff comes shipped in. Okay, a shipping box would have 4 sides to it. Now, it also has a top and a bottom. And that's where the surface area comes in. If you take a look, our surface area is the lateral area. We just talked about that. That's that P times H. Plus twice the base. Okay, 2 B's. The top and the bottom. Well, I actually put that down there. So this would be the top and this would be the bottom. Now you add those to this side, and it's going to be something like this. You're going to have a little shape like that, top and the bottom. That, by the way, is what we call a net. We'll talk a little bit more about that in just a second. The next slide talks about a prism. A prism is a polyhedron, many-sided shape, okay, where each one of these sides is a polygon. Okay, so every face is a polygon. That makes it a polyhedron. And a prism is a 3-dimensional figure made out of polygons. And there are parallel faces, which we call bases. There's the top. You'll see this little figure over here. There's the bases. There's the top, and there's the bottom. Okay, so top and bottom. And then you also have the lateral faces. Well, we just talked about the lateral area, and that would be each of these faces that are on the sides. It's not the bottom and the top, it's the from the ground up. That would be the lateral area. You have to add it all, so you'd have to slit one of those corners and unwrap it to be able to find the lateral area. Now the lateral edges would just be the height of one of those lateral faces. All right? Notice here on this triangular prism here that the bases are just triangles. Okay? So we name our base. This would be a pentagonal prism. And a triangular prism, it gets named by the shape of the base. Okay, since the base, the top and the bottom are pentagons, 5-sided polygons, then it's a pentagonal prism. The top and the bottom are the triangular shape, and so it's a triangular prism. All right, now, altitudes. An altitude of a prism is the perpendicular segment that joins the planes of the top to the bottom, okay, and that would be the height. So the altitude is the height. All right. A prism may be either right or oblique. In a right prism, the lateral faces are rectangles. That's this side over here. These are rectangles. Okay? Front, side, and back. And then top and bottom. They're all rectangles. You also have a right prism here with this in the fact that the front and the two parallel sides on this trapezoidal prism are at they're at right angles. This is a right angle, and these guys are at right angles over here as well. Okay? Oblique means that it's almost like a deck of cards that got shoved over. So if you had your deck of cards here, and all the different cards are lined up, and you shoved it a little, all of a sudden your deck of cards kind of is leaning. Well, that's where we get this oblique idea. Notice that the deck of cards didn't change volume on you, or it didn't change the surface area. They just slid over a little bit. We'll talk more about that in a bit as the chapter unfolds. But that is part of this, is a right prism and an oblique prism are really the same area. Now the height here, we have to take from this vertex to the line of the base of the bottom. Well, that's this altitude out here. And that's why we can say that altitudes and heights are the same. All right, next slide. Using a net, we just said something about a net, to find a surface area of a prism. What we're going to do is we're going to split this thing. I'm going to cut it here, and then I'm going to cut all the way around the top and all the way around the bottom, and it's going to look like this. Okay? The 5 would go here. Well, that's the same here and there and there and there and there. Those are all 5s. Okay? And then the shape kind of alternates here, so we're going to go 4 and 3 and 4 and 3 all the way around the shape on the base. Now, the top, okay, so if this is 4, then this is 4, and this is 3, and this is 4, and this is 3, and so on. Well, these guys are all 5s, all the way across here. This would also be 3, and this would also be 4, okay? So, how do you find the height of this one? Well, look at it. If you cut the box, then this shape or this length and this length are the same. Well, if this is 4, then this is 4. And this length had to match. Well, if this one's 3, then this one's 3. So I have a 3 times 4, which gives me 12, and a 4 times 3, which also gives me 12. So 12 square units, or 12 square centimeters, for each of these two top and bottom. And then here I got 5 times 4, or 20. 5 times 3, or 15. 5 again times 4, or 20. And 5 times 3 again is 15. Now if you add those all up, you will have the surface area, or the area of the net. Well, 20 and 20 is 40, so we'll take that, put it up here, 40. 15 and 15 is 30. Okay, and 12 and 12 is 24. And if we add those all up, 40 and 30 is 70, and 24 is 94. And that's 94 square centimeters. Now remember, we're finding surface area, not volume. Surface area is the area of the wrapper that went around this. Think of a Christmas present now, if you will. Wrapping paper around the Christmas present, if you made a perfect fit, which I don't think any of us can probably do, but if it was a perfect fit so that the paper fit exactly around the box, no excess, no fold over, then the area, the surface area around that box would be 94 centimeters squared. Because as soon as you lay it out flat, like this net, then you can see in square units, not cubic units. All right, surface area of this one, it's a triangular prism. That means that the bases are the triangles. Notice it's a 5, 5, and a 6 around that triangle. Okay, the height then has to be from one base to the other, and that's the 12. So H is 12. The perimeter then, if I'm going to find the lateral area for this, now remember the formula we had was surface area equals lateral area plus twice the base. So we're going to have to find the lateral area. To find the lateral area, we got to find H and P, because lateral area was P times H. Well, H is 12, P then would take this 5 and 5 and 6 and add those together, so P would be 16. By the way, those are both in centimeters. So the lateral area is 16 times 12. 16 times 12 would give me 192. Okay, so now I've got my lateral area here for this surface area. So the lateral area is 192. 192 plus 2 times the base. Well, let's find the base. Well, this triangle here, the triangle has a 5, 5, and 6. Now to find the height, or to find the area of this, I need base times height of this triangle times 1/2. So the area of a base would be 1/2 times little base times height. Well, the base is 6. So it's 1/2 times 6, but what's h? Well, the h is this measure right here, the dotted line. Okay? Now, I have a right triangle here, if I look at it this way. Right triangle with side of 3 and 3 here. So 3, hypotenuse of 5, that would give me a 3, whoops, where'd it go? 3 squared plus the height, or altitude, would be x squared equals 5 squared. We just used the Pythagorean theorem. Well, x squared then would be 25, 5 squared, minus 9, which is the 3 squared. And that gives me an x squared is 16. Okay, if x squared is 16, then x is 4. All right. Now, to find the base area of the base is 1/2 times 6 times 4. Well, 6 times 4 is 24. 1/2 of that is 12. So the area of the triangle, or the base of this prism, would be B equals 12 square centimeters. Okay? That would be the area of the base. I'm going to go ahead and put capital B there. Well, the area of the base then would be 2 times 12 for the surface area is 192 plus 2 times 12. You know that 2 times 12 is 24. So we would take our 192 and add 24 to it. And that's going to give me a total of 216, which is choice B. Okay, so the surface area is B. I'm going to have to stop here. I'll come back in and hit another one to give you some more of these problems. Hey, have a great day. See ya.